All right, so let's give this a try. We are on page 157 for calculus. Today we're going to go through maximum and minimum problems, and we'll see how this goes. Um, so max and min problems, pretty easy to identify that it's a max or a minimum that we're trying to find just by the wording of the question. We're going to have some obvious things like our setup. We should obviously draw a diagram if there's a diagram that's relevant, define any variables. If you're introducing, as soon as you're introducing a variable, you should be defining it, state what is given and what is to be found. Once we have our equation and we figure out what we're trying to minimize or maximize, then we take our derivative of that equation. We may or may not have to create that. We want to have it in one variable, therefore you're going to require a second equation. Sometimes that's implied, sometimes it's given to us. Substitute it in so that we get rid of all of our extra variables. We're going to end up just having this in one variable. Determine and test critical points. So we look at where f prime is equal to 0. We look at where f prime maybe doesn't exist. Solve for critical numbers. Test those critical numbers in any endpoints. Always remember, we're trying to find a max or a minimum. And so our graph of that changes from increasing to decreasing at a maximum, or it changes from decreasing to increasing at a minimum. So let's go through this and see how this looks. Determine two numbers whose product is 4 and whose sum of squares is a minimum. So if we are having two numbers that we introduce, so we might say something like, nope, let me get my screen back here. We might say something like x and y. Let x and y be real numbers. It doesn't necessarily say they have to be integers. I can just leave it at this. And so determine two numbers whose product is 4 and whose sum of squares is a minimum. Let's start off with the relationship between x and y, saying that our product is 4. So clearly, then therefore xy equals 4. We're going to take a step and just rearrange that. Y is equal to 4 over x, because we're going to be simplifying some stuff here in a second. All right. Second step of this, we're going to create our next equation, and it says we have the sum of squares is a minimum. We are trying to minimize, so let's write this as min will equal x squared plus y squared. We have the sum of their squares. The fact that we are trying to minimize that, so let's just call that min for now. Therefore, min equals, let's now do our substitution, x squared plus, now it was y was equal to 4 over x, so we have 4 over x squared. Now this gets a little interesting here. We're going to take min prime. We're going to take our first derivative. We're going to differentiate both sides of this with respect to x. This ends up being 2x. This ends up being, we have 16 over x to the 2. It means it is 16 times x to the negative 2. Makes this negative 32. Negative 3. Now, what happens to this left side of this? We have the minimum, and we're taking the first derivative. Remember that minimum is just a number. It's just a constant. And so when we take our first derivative, that is equal to 0. So here we have 0 is equal to 2x minus 32, x to the negative 3. This is where common factoring comes into place. And so we are going to common factor out 2x to the negative 3. We take the lesser of our 2 degrees. We factor 2x to the negative 3 out of that first term, gives me x to the 4. I factor out 2, x to the negative 3, gives me x to the 4 minus 16. That is now a difference of squares. Squared plus 4, x squared minus 4, and then the x squared minus 4 is this. So we complete that. Okay. So we have critical numbers. Let's do our next step. Just change colors again. Critical numbers. What do we have? Here we have x is -2. From the next one, we have x is +2. But also from here, we have a critical number of 0. Remember, it's in the denominator. X can't be 0. And that goes all the way back to our original function. So that ends up being our critical number, where we have to look at this. And so we end up with a number line. I'm just going to call this number line f prime. And we want to look to see what happens around -2 and around 0 and around +2. Do that. Numbers less than -2. Keep in mind, by the way, let's just come back to this for a second. This one, x squared plus 4, realize that that's never equal to 0, right? When you square a number, it's non-negative, and then when you add 4, for sure, that's got to be positive. So that factor can't make it equal to 0. Okay, so we have numbers less than -2. So if I'm looking in this zone here, I'm looking at, see, so a number like -3, what does -3 do in for each of these terms? It makes this -3 is going to be 2 over -3 cubed, so that's going to be negative. This will be positive. -3 plus 2 will be negative. -3 minus 2 will be negative. So we have 3 negatives multiplying there, gives me negative in that zone. Between -2 to 0, so when x is, say, -1, it changes. This one's now going to be this one's now going to be positive. Those other two are still negative. So we multiply that all together. That gives us a positive. When x is +1, so let's say in that third interval, when x is +1, we have positive times positive times negative makes this negative. And then in the last zone, they are all positive. Okay. So from there, we can conclude. Let's see up here. Therefore, we probably draw a vertical line to indicate we're continuing on here. We have the fact that is increasing on from -2 to 0, union 2 to infinity, and it is decreasing on -infinity, -2, union 0 to 2. So where do you have a minimum? You're having a minimum where you go from decreasing to increasing. So when you go from decreasing to increasing, so at -2, so x is equal to -2, therefore y is equal to -2. Or also when x equals +2, it is decreasing and then it starts increasing, and therefore y is +2. So our numbers are -2, -2, or +2, +2. All right. Moving ahead. 2,700 square centimeters of material is available to make a box with a square base open on top. Determine the largest possible volume of a box. Okay, so let's try to draw a box here. We've got open on top. The base is square. It's important here in that length and width are the same. I can see that inside edge. And it has a height of, let's call this y. We have 2,700 square centimeters of material, so that's referring to surface area. So what do we have? We have let's start with the formula. Let's start with the formula here. Let's start with surface area that we are dealing with. We're dealing with x squared for the bottom of the box. We're dealing with the sides of the box are each xy, and we have 4 of them. So there's my area formula for how much material is available to make your box. X squared plus 4xy, and it's 2,700. Solving this for y, we want to get this into one variable so we can, it's going to be easier to solve for y than it is for x for sure. So let's just 4xy equals x squared minus 2,700. And then y is equal to, no it's not, no it's not, delete, delete. It seemed a little weird. Okay, good catch, guys. Thank you. And so we have 4xy is equal to 2,700 minus x squared. And then when we divide both sides by 4x, we end up with 2,700 minus x squared over 4x. Let's just leave it at that for now. And let's scroll down a little bit. Now let's start with area. This is what we are trying to minimize. No, we are trying to find our largest possible volume of a box. Okay. Changing colors here. Largest possible volume of a box. What is our volume? Our volume is equal to squared y. And we're trying to maximize this. Vmax, if you want to call it, is equal to x squared y. So what do we have here? We've got x squared, and then we substitute in, this ends up being 2,700 minus x squared over 4x. We simplify this a little bit. We can divide all of this by 4. We can distribute x squared, and we get 675 x minus 1/4. Just dividing 2,700 by 4. Now, when we take our first derivative, this simplifies a lot. This is just 675 minus 3/4 x squared. And remember that minimum volume, that's just a number. So when we take our derivative, that's just equal to 0. So we end up with, let's common factor out -3/4. And let's see what we get here. If we common factor out -3/4, leaves us with x squared minus, and then common factor, dividing 675 by 3/4 means divide by 3, multiply by 4, Works out super nicely. This is x squared minus 900. We end up with 3/4 plus 30x minus 30. We have x equals plus or minus 30. And we are ready to go. I'm going to change the size of this pen a little bit. Let's see if this is better or worse. We'll draw this, and so here's negative 30. And here's positive 30. When we do this number line, don't include 0 if it's not one of your critical numbers. I know it kind of feels weird to not have 0 on your number line when it's clearly in between those. And then if we're looking at numbers that are less than negative 30, this ends up being negative times less than negative 30, so negative 40 makes this negative and makes this negative. So in this first interval, we have a negative product. In between, when one of them changes to, well, we can make this just 0. Negative 3/4 times 30 times negative 30 makes this positive in here. And then in our last section, this ends up being negative. Therefore, increasing, or it's increasing on negative 30 to 30. Decreasing on infinity, negative 30, union 30, infinity. And therefore, where we have a maximum, we have a maximum where we switch from increasing to decreasing. So where do we switch from increasing to decreasing? That happens right here, switching from increasing to decreasing. Or maximum x equals 30 centimeters, your base length, and y ends up being equal to, y will end up being equal to, what do we have here? Let's just figure this 2,700. 700 is equal to 30 squared plus 4 30 times y. And we figure that out. 2,700 minus 900 is 1,800 divided by 120 ends up being 15 centimeters is your height. Next one. Okay, so each of these ramps up a little bit, starts to get a little trickier. Determine the points on the curve y equals x squared. Okay, so kind of a nice, easy parabola. No big deal. Y is equal to x squared. Determine the points on this parabola. Oh, that's a little wonky. Okay, that's closest to 18 comma 0. So 18 comma 0 is going to be way over here. 18 comma 0 is going to be way over here. We're trying to find our point that is closest to the parabola. We are trying to minimize that distance. If we're trying to minimize that distance, what's the coordinate at that point? Well, of course, the coordinate of this unknown point is x, is your x value, and your y value is just from your formula, x squared. And we've got Pythagorean theorem. We have the distance between these. So if we look at Pythagorean theorem with this, we will have d squared. This is what we are trying to minimize. Now the length of this is going to be, the length of this right here is going to be x minus 18. So if this is x, then this ends up being x minus 18 squared y minus 0 squared. Notice that essentially 18 comma 0, we can just put in those as coordinates. Notice that that would really be a circle centered at 18 comma 0. And so our point on the parabola would be on that circle with a radius of d. Okay, let's keep moving forward. We know that y is equal to x squared, so therefore this becomes, very quickly, this breaks down to x minus 18 squared x squared minus 0. We're going to have to simplify this a little bit. Excuse me, x to the 4, x squared minus 36x. Is that 324? Just multiplying out that binomial. And here's where we take our derivative. Here's where we need to remember that d squared is just a number. And when we take our first derivative of that, this is d squared prime gives us 4x cubed plus 2x minus 36. This is equal to 0. We divide all of this by 2. We don't even need to really just factor it. We can divide it both sides because it's 0 over 2 makes this 2x cubed plus x minus 8. All right. We end up with, how do I scroll here? Here we go. We could use factor theorem to do this. I'm going to kind of skip some of this. We could try numbers like +1 and -1 to see if that's a factor. It's not going to make it equal to 0, but 2 does. When x equals 2, when x equals 2, this will equal 0. X equals 2, this will equal 0. So therefore, and this was 30-1 coming back, x minus 2 is a factor. X minus 2 is a factor. We end up with 2 on our outside of our synthetic division. We set up our synthetic division. 2x cubed is there. Remember, we need a 0 for 0 x squareds. We've got 1x and we've got minus 18. And let's go ahead and synthetic divide. This has been a while since we've done this. 2 comes down, we multiply. 4, we add. We multiply, makes that 8. We add, that's 9. We multiply. This is 18. We add them down. This is 0, and it better be. Oh, that's not a very happy face. That looks, there we go. That's a little happier. 0. Okay, it's got to be 0 because that's how we chose that to be there. So therefore, 0 is equal to x minus 2, and now we factored it to be 2x squared plus 4x plus 9. We could look at factoring that further. We don't know how to factor two numbers that multiply to 18 and add to 4. And so let's quickly check our discriminant. Because our discriminant is less than 0, discriminant is b squared minus 4ac. This would be 16 minus 4 times 2 times 9 is less than 0. That tells us that we have no roots from that trinomial. Therefore, no real roots. remember that meant that when we had 2x squared, sorry, there's my square there, 2x squared plus 4x plus 9, if our discriminant's less than 0, that meant this. And if that's the case, then we have no real roots. Then it's either always positive or it's always negative. And when x is 0, that's going to make this, because this is positive 9, so therefore always positive. Therefore always positive. Therefore, x minus 2 is our critical number. X minus 2, sorry, x equals 2 is our critical number. Our number line looks like this. There's 2 in the middle. Numbers less than 2, such as 0, makes it negative times positive. So this is going to be negative. When x is greater than 2, like 3, 3 minus 2 makes this positive times this is always going to be positive. So therefore, that's positive. Therefore, it's decreasing. Decreasing on negative infinity. Positive 2 is increasing afterwards. To infinity. And therefore, it's decreasing and increasing, so we have a minimum at f of 2 equal to 4. So therefore, 2 comma 4. That's it. Next page. Question number 4, determine the radius and height of a right circular cylinder, largest volume that can be inscribed in a right circular cone, radius 6 and a height of 10. Holy junk, what's going on? We've got a cylinder. It's a right cylinder, which just means that the base and the sides of the cylinder erase please. There we go. It just means this is at a right angle. But this thing is inscribed in a right circular cone. So let me try a different color here. And I'm going to make a cone. So the center of the cylinder and the center of the cone are in the same place. It tells us that the right circular cone has a radius of 6. It has a height of 10 centimeters. Wow. Determine the radius and the height of a right circular cylinder of largest volume. So we are trying to maximize the cylinder that can be inscribed in this right circular cone. So if you think about it, there's lots of different cylinders that we could put in there. We could put in a tall, skinny cylinder that is going to be inscribed. We could put in a short, fat cylinder that's going to be inscribed in there. Now I've just kind of wrecked my diagram, but that's kind of what's going on, is we are trying to find the most voluminous cylinder that we can go in there. Let's draw a cross section of this. And our cross section is going to look like this. Let's do this still in green because this is the sides of the cone. And if I have this, it's going to be my isosceles triangle. It looks like this. So if that's my cross section of the cone, my cross section of the cylinder will just look like a rectangle in here. And if R is my radius of the cone, it's going to look like this. And if H is my height of the cylinder, it's going to be looking like that, which tells me that the rest of this radius is 6 minus R, and the rest of this height is 10 minus R. Here we don't have some obvious things going on here. So R is my radius cylinder. Don't just say radius. Because that's not really very clear anymore. But the radius of my cylinder in centimeters, H is equal to my height. The cylinder in centimeters. And we have some similar triangles going on. So if we look at these triangles in here, if I compare this triangle I have 6 minus R over H as a ratio. And what is that going to be compared to? Now, if I compare to this, still it's a similar triangle. But what do we have for the radius is 6, and the height of that whole thing is 10. We algebra this up, and we got H equals 6 minus R over 6. 5, 6 minus R over 3. So we have H can be expressed in terms of R, so we're going to be able to get rid of one of our variables. That's kind of an important piece. All right, so now we can start to move forward. We have volume that we're trying to maximize. We're trying to maximize our volume of a cylinder. So volume, my cylinder. Volume of any prism is the area of its base, which is pi r squared, times its height. So we have volume is equal to pi r squared. And now our H we found to be 5/3. 6 minus R. We simplify that and distribute. And we get, so 5 times 6 is 30, divided by 3 is 10. Pi r squared. 5 times negative r divided by 3 is 5 pi r cubed minus 5 pi r cubed over 3. And this is how my volume formula simplifies. We normally wouldn't do that, right? But we're going to take a derivative of that, so it's going to be easiest once it's written in that form. So V prime is equal to 20 pi r minus 3 times 5, but it's being divided by 3, so it's minus 5 pi r squared. Simplifies super nicely. Remember that V prime is now just equal to 0. Let's factor this, and this is 5 pi r. Behind 4 r. So this happens when r is equal to 0 or r is equal to 4. Those are our two critical numbers. Here's 0, Or we've got this in factored form that helps us out, because when r is a -1, so when r is -1, if we're looking in this region here, we end up with this ends up being negative, this ends up being 4 minus -1 is positive, so negative times positive. In this interval is negative. Between 0 and 4, so a number like 1 ends up being positive, times positive makes this is positive. And then this last zone, when r is 5, this is positive, this ends up being negative. Boom, there it is. We always need to state our intervals of increasing, decreasing, increasing on 0 to 4, decreasing on infinity to 0, 4 to infinity. So we are trying to find a maximum. So we're trying to find where it changes from increasing to decreasing. So therefore, when r is equal to 4, therefore h is equal to, let's just run 4 through this formula here. 5 times 2 over 3 is 10/3. And so we have our units on this is in centimeters and on centimeters. Does it ask for the volume? Determine the radius and height of the right circular of largest volume. So it is not asking necessarily for volume, but you could fairly quickly calculate that it's 160 pi over 3 cubic centimeters if we're doing that. All right, so lots going on with this question. The biggest piece really was right at the start, is A, trying to get your head around what this means in terms of our diagram. And then our next, making this cross-section diagram. We've seen this before where we take a cross-section diagram and create this relationship between R and H so that we can isolate one of the variables so we can solve it for H. And then once we had that, the rest of this was really pretty easy. Last one for this lesson. It says boat A is 40 kilometers west of boat B. Okay. When we do these questions, we should always have west is to the left on our diagram, north is up. If boat A is 40 kilometers west of boat B, and it sails east at 20 kilometers per hour. So here's A right now. It's sailing to where boat B is. Boat B, starting at the same time, starts to sail north at 10 kilometers per hour. Determine the time when the boats are together, are closest together. Not together, they're never going to be together. So we are trying to minimize, if we call this D for a distance, we are trying to minimize that. T is equal to time. Oh, do we need that? Sure we do. T is equal to time in hours. If B is the distance boat B is traveled, A is your, what do we want here? We want A is going to be our, this length here is going to be our distance of boat A Okay. So this one ends up being pretty straightforward. This distance here, this distance that boat B has traveled in T hours, it's sailing north at 10 kilometers per hour. So this one is just 10T. That one's not too bad. This one's a little trickier. Different color just so we can see it more. After T hours, B travels 10T. After T hours, A travels 20T, right? Because it's going 20 kilometers per hour. And so this ends up being 40 minus 20T. Kind of just like this is just really 0 plus 10T. If 10T is how far that boat B goes, if 20T is how far boat A goes, then that side of the triangle is 40 minus 20T. We will need that when we do Pythagorean theorem. D squared is equal to 40 minus 20T squared 10T squared. T squared is equal to, what do we have here? We have 1600 minus 1600T, not 800. 400T 100, oh, sorry, T squared plus 100 T squared. All of this together is 500T squared minus 1600T 1600. When we take our first derivative, a lot of this is going to melt away. T2 prime is equal to 1000T 1600. Factor it or pretty easily see uh, 1.6. 1.6. T is 0, this ends up being negative. And T is 2, this ends up being positive. At 1.6, it ends up being 0. Therefore, it is increasing negative infinity to 1.6, increasing 1.6 to infinity, which makes sense. Like after 1.6 hours, the distance between them is always going to be increasing. I guess technically, maybe we should have started this at 0, 1.6 for decreasing. That's okay. To answer this question, we therefore the boats closest 1.6 hours. Minimize that distance, and that's it. So let me just stop the recording.